Good morning everyone. Today we are going to discuss the next chapter, that is the redox. What is redox? Redox is the combination of the reduction and oxidation. Then the combination of the reduction and oxidation is called the redox. Redox is a couple reaction. You can say that the reduction always carried out with the oxidation and oxidation is always carried out with the reduction. Oxidation and reduction can't run separately. So that is called a redox reaction. What is redox? What is the concept of the redox? The classical concept of the redox says that the addition of oxygen is called oxidation and addition of hydrogen is called reduction, or vice versa. That means the addition of oxygen is called oxidation, removal of hydrogen is called oxidation, as well as the addition of hydrogen or removal of oxygen is called the reduction. So this was the classical concept. For example, if you are saying that the C plus O2 gives CO2, here you can see that the addition of oxygen is taking place and as a result this is the process of oxidation. But when you will see C plus H2 gives CH4, here it is the addition of hydrogen and this is called the process of reduction. So the addition of oxygen or the removal of hydrogen is called oxidation and the addition of hydrogen or removal of oxygen is called the reduction. But in all the reactions, the oxygen and hydrogen are not participating. For example, this reaction, this is the SnCl2 stannous chloride reacting with the FeCl3 ferric chloride to give stannous chloride and ferrous chloride. इस रिएक्शन में आप देख सकते हैं द ऑक्सीडेशन एंड रिडक्शन बोथ आर टेकिंग प्लेस. इट इज अ रिडॉक्स रिएक्शन बट नो ऑक्सीजन एंड नाइदर एनी हाइड्रोजन. तो क्लासिकल कॉन्सेप्ट से हम कैसे जानेंगे कि वेदर इट इज अ रिडॉक्स और नॉट? वी आर नॉट कैपेबल टू आइडेंटिफाई वेदर इट इज रिडॉक्स और नॉट. इवन सम ऑफ द people say that the addition of the negative system is called electronegative system is called oxidation, addition of electropositive system is called reduction. But when we see different species, sometimes the comparative study takes place, which one is more electronegative, less electronegative, surely the process becomes complicated. यानी कि oxygen and hydrogen is not the only factor which can explain the process of reduction. Why? Because they are not the compulsory portion of the reaction. साइंटिस्टों ने इसके बाद डिस्कस किया और उन्होंने कहा कि कुछ ऐसा फैक्टर लेते हैं रिडॉक्स को एक्सप्लेन करने के लिए जो हर एक केमिकल रिएक्शन में होना मस्ट हो, जो हर एक रिएक्शन मिले ही. क्लासिफिकेशन के लिए या फिर किसी प्रोसेस के आइडेंटिफिकेशन के लिए ऐसा ही बेसिस बेटर होता है कि जो हर एक प्रोसेस में वो दिखाई पड़े. सो दे थिंक दैट व्हाट विल बी दैट पार्टिकल, that may be the fundamental particle, electron, proton and neutron. Without electron, proton and neutron the reaction is not going to take place. In which proton and neutrons are surviving in the nucleus, और nucleus में survive करेगा तो nucleus force के साथ होगा. Surely they are not capable to take part in the reaction because of that strong force, that is the nuclear force. So what are the particles which can participate in the reaction? That particle is called the electron, which is not surviving in the nucleus, that is outside the nucleus. So on the basis of the electron we said that what is the redox, and this method is called the ion electron method. So what is the concept according to ion electron method about the redox? According to this concept, the addition of electron is called reduction and the removal of electron is called oxidation. That means addition of electron is reduction, removal of electron is reduction. Just we are trying to see some of the reactions where we are going to identify whether the reaction is redox or not. So we are taking this reaction, that is the stannous chloride reacting with the ferric chloride giving stannic and ferrous chloride. First of all, we will write the reaction in the form of the ionic reaction. So when you will ionize the system, it will form Sn plus 2 plus 2Cl minus. As the chlorine contains 2 negative charge, the stannous will counter it. Now 2F3 plus 3 plus 6 Cl minus 3 to the 6. Now Sn plus 4, 4Cl minus, and 2PF3 plus 3 and 6Cl minus. Now in this way, sorry, 4Cl minus. In this way we have written the reaction in the form of the ionic reaction. Now we are cancelling those of the factors which are common on the left and right hand side. So here you can see total 8 chloride and again 8 chloride ion. कभी कभार आप कहते हैं कि सर स्टेनस भी तो कैंसिल किया जा सकता था, बट दिस वन इज Sn plus 2, Sn plus 4, both are not identical, and similarly Fe plus 3 and Fe plus 2 again not identical. ये स्टेनस है, ये स्टेनिक है, ये फेरिक है, ये फेरस है, इन्हें आपस में कैंसिल करना पॉसिबल नहीं है. Now we are breaking the reaction in the half reaction. That means the first half is stannous Sn plus 2 is turning in the form of Sn plus 4, and the second half, that is the iron half, that is the Fe plus 3 is turning in the form of Fe plus 2. Now when you will balance the reaction with the help of the electron, we have to balance the charge here. Then what is the 2 electrons here, so total charge plus 2 plus 4 minus 2, that is the plus 2 again. Similarly in this case 2 3 जा 6 plus 6 charge, 2 2 जा 4 plus 4 charge, तो हम यहाँ पे 2 इलेक्ट्रॉन ऐड कर देते हैं. So the reaction is balanced now. Now in this reaction देखिए ये क्या कर रहा है, Sn plus 2 is turning in the form of Sn plus 4 by losing 2 electron, and loss of electron is called oxidation. And similarly when you will see the next one, iron by taking 2 electron, that means the gain of electron, और gain of electron क्या होता है, this is the reduction. So according to this one, the loss of electron is called oxidation and gain of electron is called reduction. अब हम ऐसा जानते हैं कि every reaction have the electron, every reaction participate due to the electron, and if they have the electron, there must be the exchange of electron will take place, that will suggest whether the reaction is redox or not. लेकिन प्रॉब्लम यहाँ पर भी खत्म नहीं हुई, प्रॉब्लम वैसे ही कंटिन्यू थी. यहाँ पे जब हमने देखा तो कुछ रिएक्शंस जो आयनाइजेबल थे रिएक्टेंट्स, उनको तो आयनाइज हम करने के लिए कैपेबल थे, लेकिन क्या सारे मॉलिक्यूल्स को आयनाइज किया जा सकता है? क्या सारे मॉलिक्यूल्स को आयन और इलेक्ट्रॉन्स के फॉर्म में लिखना पॉसिबल है? श्योरली नॉट. व्हाई? बिकॉज सम ऑफ द मॉलिक्यूल्स आर आयनिक बाय द नेचर, they have the electrovalent bond, and some of the other molecules are non-ionic by the nature because they have the covalent bond, they have the coordinate bond. And if they are not dissociating in the form of the particles, then how you will identify whether the reaction is redox or not? You know many of the reactions where the bonds are the covalent, almost all the organic compounds, you can take the example, they are covalent, and if they are not breaking in the form of their ion, how will you find the electron and ion? That's not possible. So it is not the right method to find the redox, nature of redox on the basis of the electron, because electron is not a factor which can be easily calculated in those of the reactions which are considered as a covalent reaction, that is the reaction of the covalent compound. तो covalent compounds के केस में ये ion electron method नहीं चल पाता. अब इस मेथड के जाने के बाद, इस मेथड के फेल होने के बाद एक नया मेथड आया. इस नए मेथड को हम कहते हैं रिडॉक्स, दैट इज द ऑक्सीडेशन नंबर मेथड. एंड अकॉर्डिंग टू द ऑक्सीडेशन नंबर वी से दैट द इंक्रीज इन ऑक्सीडेशन नंबर इज कॉल्ड ऑक्सीडेशन and decrease in oxidation number is called reduction. So we are going to study according to the oxidation number, we are going to study redox according to the oxidation number, and before that we are studying some of the oxidation numbers. जनरली होता क्या है, ऑक्सीडेशन नंबर निकालने के लिए हम दूसरे ऑक्सीडेशन नंबर के हेल्प से कंपेयर करके हम ऑक्सीडेशन नंबर्स फाइंड करते हैं. सो वी आर गोइंग टू स्टडी अबाउट द ऑक्सीडेशन नंबर्स. So some of the oxidation numbers are for the first group. What are the members of the first group? Lithium, sodium, potassium, rubidium, cesium and francium. Normally ऊपर के 3 एलिमेंट्स के बारे में ही हम स्टडी करते हैं, लिथियम, सोडियम एंड पोटेशियम. नीचे वाले एलिमेंट्स फ्रीक्वेंटली किसी रिएक्शन में आते नहीं हैं. So for the first group, what is the oxidation that is the plus 1. For the second group, it is plus 2. For group 13, it is plus 3. In the group second, the elements are the beryllium, magnesium, calcium, etc. And in the group third, boron, aluminium, gallium, etc. Now, the group 17, which is called halogen. आपको मालूम है हेलोजन में सारे 17 ग्रुप के मेंबर्स नहीं होते, एस्टाटीन इस कैटेगरी में नहीं आता, सो इट्स ओनली फ्लोरीन, क्लोरीन, ब्रोमीन एंड आयोडीन. So for these of the element, the oxidation state is -1. For oxygen, it's -2. If the oxygen is surviving as a peroxide, it have the oxidation number -1. For the hydrogen, it is +1. Similarly, for the atom, the oxidation state is 0. For molecule, again 0. For ions, it is charged. And atom in homomolecules, homoatomic molecule, have oxidation state 0. So these are the sum of the oxidation state what we need to know. इतने ऑक्सीडेशन स्टेट तो आपको लर्न करने पड़ेंगे, इसके बेसिस पे ही हम दूसरे ऑक्सीडेशन स्टेट्स को निकालते हैं. Actually it is suggesting that partially or completely how many electrons are transferred by any of the system, how many electron a system donates or takes, that is called the oxidation number. You know well that the first group element have 1 electron in their valence shell, so that is donating 1 electron. This one have 2 electrons, so donating 2 electrons. This is 3 electron. And the group 17, that is the halogen family, have total 7 electron in their valence shell, so that have a tendency to gain 1 electron to complete their octet. So in this way, how many electron they are completely or partially taking or donating, that is called their oxidation number. So on this basis, we will study the oxidation number of the different elements. You can just note it down, and then we will see finding the oxidation number of some of the elements, that how to find the oxidation number of the elements. So here we are trying to find the oxidation number of some of the element for which we don't know the oxidation number. Here we are trying to find the oxidation number of the Mn. I have underlined it, and in this case we are going to find the oxidation number for the iron. Generally the D block elements are known for their variable valency and oxidation state. So generally we need to find the oxidation state of these of the elements. So if you will see this one KMnO4, then what is the oxidation state of the potassium? First group element +1. And what is the oxidation number of oxygen? -2. आपने पहले देख रखा है. Then what will be the oxidation number of Mn? Just let that the oxidation number of Mn be X. Now we can write that the oxidation state of the potassium +1 plus oxidation number of Mn X plus oxidation number of oxygen, that is -2 into 4, as it is a 4 atom, equal to what is overall species. ये पूरा species है क्या? It is a molecule. And what is the oxidation state of the molecule? That is 0. So equal to 0. Now in this case, when you will solve, it will be +1 plus x minus 8 equal to 0, or x minus 7 equal to 0, or x equal to +7. So the oxidation state of the manganese is +7 in this compound, that is the KMnO4. I think it's clear to all of you. Okay. Now we are going to see the next one, that is the iron. We are considering that the oxidation state of iron be X. Let the oxidation state of iron be X. The oxidation state of potassium is +1, that is the first group element. What's about the cyanide? Cyanide is an ion, Cn negative, having single negative charge, and for the ions the charge is considered as the oxidation number. This is the oxidation number of the carbon and nitrogen, that is the cyanide, not individually carbon or nitrogen. So when you will try to find the oxidation state for the potassium plus 1 into 4, the oxidation state of iron is X, and for the cyanide minus 1 into 6, and this is overall a molecule, so 0. We are just solving it, and after solving we will get the value. So 1 into 4 equal to 4 plus X minus 6 equal to 0, or X minus 2 equal to 0, and X equal to plus 2. So in this way we will find the oxidation number of the elements. Now we are going to see some of the paradox. कुछ ऐसे भी कंपाउंड्स होते हैं जिसमें ऑक्सीडेशन स्टेट दिखाई कुछ और पड़ता है और रियल में कुछ और होता है. फॉर एग्जांपल वी आर टेकिंग Ki3. If you will have to find the oxidation state of the iodine, then what will be the oxidation state of iodine? If we are considering the oxidation state of iodine be X and the oxidation state of potassium is always plus 1, तो होगा क्या? plus 1 plus 3X, 3 iodines के लिए equal to 0, then X equal to minus 1 by 3. क्या ऐसा ऑक्सीडेशन स्टेट पॉसिबल है? क्या पार्शियल इलेक्ट्रॉन्स मूव कर सकते हैं, 1/3 इलेक्ट्रॉन मूव कर सकता है? श्योरली नॉट. और अगर ऐसा पॉसिबल नहीं है तो ऐसा आंसर ही क्यों आ रहा है? दिस फैक्टर कैन बी एक्सप्लेन्ड ओनली ऑन द बेसिस ऑफ द स्ट्रक्चर ऑफ द मॉलिक्यूल. सो आई एम जस्ट ट्राइंग टू ड्रा द स्ट्रक्चर. द स्ट्रक्चर ऑफ द Ki3 is, this is the structure. Now what is the oxidation state? This is the potassium, so plus 1. What is the oxidation state of first iodine? When you will see the iodine, it is attached to the HOMO atom. खुद के साथ अटैच होके इलेक्ट्रॉन ट्रांसफर पॉसिबल नहीं है, so the oxidation state will be 0. और सेम इस केस में यहाँ पर भी सेम एटम के साथ है, HOMO एटम के साथ है, तो ऑक्सीडेशन स्टेट will be again 0. But this one is attached along with the HOMO atom as well as the potassium, so the oxidation state will be minus 1. So you can say that there is no any fractional oxidation state. minus 1 0 0. तो यहाँ पे फ्रैक्शनल क्यों आ गया? यहाँ पे फ्रैक्शनल इसलिए आया because this value is the average value of these three. That means minus 1 upon number of iodine atom 3. That is minus 1 by 3. These type of system which seems something else and which are actually something different, they are called the paradox. यहाँ पे दिखाई कुछ और पड़ता है ऑक्सीडेशन स्टेट और होता कुछ और है. मैं आपको एक और एग्जांपल एक्सप्लेन करके बताने की कोशिश करता हूँ. See, in this compound, what will be the oxidation state of the iron? If you will consider the oxidation state of the single atom of iron be X, then 3 iron का क्या हो जाएगा? 3X plus minus 2 into 4 equal to G, या 3X minus 8 equal to 0, और X equal to 8 by 3. Again a fractional value 8 by 3. लेकिन रियल में क्या है वो तो कब पता चलेगा? When you will draw the structure of the compound. So I am just trying to draw the structure of the compound, that is the Fe3O4. The structure of the compound is oxygen making double bond with the iron, again single bond, single bond, single bond, single bond, and double bond O. In this way, when you will find the oxidation state of the iron, the first one, the oxidation state of oxygen is minus 2, again minus 2, I can write minus 1 and minus 1 because one electron is shared by this iron and one electron with this iron, again minus 1 and minus 2. In this way, when you will try to find the oxidation state of the first iron, minus 2 and minus 1, then what will be the oxidation state of the iron? काउंटर करेगा तो इसका चार्ज नेचर अपोजिट हो जाएगा, that is the plus 3. Similarly for the next one, again it is plus 2 minus 1 minus 1, and for this one minus 1 minus 2 minus 3, so it is the plus 3. I think you get that how we are finding the oxidation state. तो पहले आयरन के लिए प्लस 3, क्योंकि इस ऑक्सीजन का माइनस 2, इससे एक इलेक्ट्रॉन हुआ, तो यहाँ पे टोटल प्लस 3, एक और एक यानी प्लस 2 एंड प्लस 3. So no any iron atom have the fractional oxidation state. The first one have the oxidation state plus 3, second one have plus 2, and third one have plus 3. What is the overall sum of the oxidation state? Plus 3 plus 2 plus 3 यानी कि plus 8. And how many irons are there? 3. So when you will try to find the value, every value, it will be 8 by 3. So the paradox can be explained only on the basis of their molecular structure. In absence of molecular structure, we are not able to explain the paradox. In the next video, we will discuss that how to find the redox, whether the reaction is redox or not. And then we will discuss about the balancing of the redox reaction, which is one of the most important topic of the chapter. Till then, thank you. Have a nice day.